Learning from the Experts series are available on NYSERDA's website at the address on this slide. All participants have been muted. We'll have time for Q&A following the presentation, so please use the Slido feature to submit your questions. Next slide, please. New York State is working to advance the responsible and cost-effective development of offshore wind as part of a diverse energy supply. Offshore wind is a critical component in achieving the state's energy reliability and decarbonization goals. While offshore wind has been providing clean energy to other parts of the world for several decades, this industry is brand new to New Yorkers. To provide interested stakeholders and members of the public with accessible, impartial information and opportunities for engagement on specific topics of interest, NYSERDA is hosting this educational webinar series called Learning from the Experts to connect the public with independent experts in key topic areas in offshore wind. We endeavor to select learning from the expert speakers based on their expertise, not necessarily for an alignment of opinions with NYSERDA or the state of New York. Please note that the views and opinions expressed in this presentation are those of the presenter. Next slide, please. It's now my pleasure to introduce Serene Hamsho. Serene is an award-winning energy technologist, former MIT visiting scientist, and public speaker. With over 15 years of experience, Serene has been a key player in developing multi-billion-dollar projects for top leaders in the wind energy sector. Currently, she serves as the president of the American Offshore Wind Academy, an industry-led initiative dedicated to empowering offshore wind development in the United States and globally. It's now my pleasure to turn it over to Serene. Thank you.
All right, thank you, Peter, for the kind introduction, and good afternoon, everyone. It's a pleasure to join you all today and to be part of this NYSERDA webinar. I'm very much excited to talk about a topic that's not just transforming our industry, the offshore wind, but also the entire world. So in the next 40, 50 minutes, I'll walk you through how AI is being applied across the offshore wind life cycle, and also I'll share some real world examples of how it's improving performance and sustainability as well. Next slide, please. So just a quick look at the agenda. I'll start with a short introduction about myself and the Academy. Then I'll give an overview of AI fundamentals just to make sure that we're all on the same page of understanding the terms. Then we will look at how AI is applied throughout the offshore wind project lifecycle. And then I'll follow by a section on the future AI opportunities, some of the more innovative or emerging applications on the horizon, especially for those of you who are coming from an entrepreneurship background, and for those of you who are interested in diving into or venturing into the offshore wind industry with the new ideas. And finally, I'll just wrap with the Q&A discussion. So please keep your questions coming throughout the session. I don't see them, but the team in the background are managing these questions. Next slide, please. A little bit about me before we dive into the main topic. I'm originally from Syria and also French and American citizen, so I worked in all these three continents. Academically, I studied electronic engineering and later earned my master's degree in sustainable development and started my PhD in the same domain. And yes, that's me right in the middle of the front row. Although I was the only female engineer in my class, I was lucky enough to be surrounded with dozens of nutritionists and nutrition specialists, the one you see with the green ribbons in the back row. So I'd like to say that I owe my great health tips to them. I've been in the wind energy sector for over 15 years now, spanning both onshore and offshore, and across both engineering and leadership roles. Before starting the Offshore Wind Academy, I led the technology and innovation department at Hexicon, and I also led the engineering teams for offshore wind projects in the United States. And I like to say that I began my career at GE working in the very same building where Thomas Edison once worked. It was incredibly inspiring to walk past his desk every day and read his words. I find out what the world needs, then I proceed to invent it. And yes, that's my daughter in the picture, who's now a teenager. At that time, Probably she was much more fascinated by the pink balloon than the entire Thomas Edison's legacy. Next slide, please. I'd like to take a minute also to introduce the Offshore Wind Academy, which I currently lead. It was founded in 2023 with a great partnership with the top industry leaders. The Academy was created to close one of the biggest gaps in our industry, the shortage of qualified professionals who truly understand not just the technical, but technical, economic, and environmental aspects of offshore wind. And that's why we go by experts teaching experts, because we focus on high-level professional training rather than just vocational skills, as our mission is to accelerate the transition into offshore wind. Just over the past year, as you can see on the screen, we have trained more than 450 professionals across 31 countries, and we have over 115 subject matter experts from leading companies and institutes. As you can see on the map, we now have an international presence with active collaborations in the US, Europe, Middle East, and Asia Pacific, where we do both in-person and online training. And of course, one of the most important technologies shaping that future and shaping how we trade is artificial intelligence, which brings us to the focus of today's session. Next slide. So let's start with why AI matters to this industry in the first place. The offshore wind industry, although it's a niche industry, but it's expanding rapidly. And much of the process is still very manual. Engineers spending days or weeks analyzing site data or planning operations that AI can handle in minutes. And to meet our 2035 and 2050 clean energy targets, we need digital acceleration, and AI provides that edge. Just a simple example about why AI matters in our industry: Google DeepMind used AI to predict wind farm output 36 hours ahead of time. That allowed operators to plan energy sales better than or increase the profits by around 20%. That's what AI does. It turns raw data into foresights. Instead of reacting to problems, now we can start predicting them. Next slide. Before we dive into the applications, I'd like to make sure we're all on the same page about what AI actually is, because there are some buzzwords that are going around these days. So when people say AI, they often mean different things. So let's break it down simply. AI, or artificial intelligence, means giving computers the ability to think or decide in a way that seems intelligent, like human ability or more. In other words, mimic human reasoning. For example, your phone camera detecting faces, or your email sorting spam and important emails. That's AI. Then we have the machine learning, which is a subset of AI. As the name implies, machine learning, the machine is learning. It is when computer improves its performance through experience. Like it learns from data. For example, Netflix or YouTube, recommending what you might want to watch next based on what you have already seen. And if you are on social media like me, specifically on Instagram, when you go to feed, you will notice that if you click on one post or one reel, the entire feed will switch into that mode. So of course, it depends on how optimized and how trained your model is. You can get precise and accurate data. For example, I'm actually due, I'm expecting a baby in a couple of weeks, and it's not surprising to see that all my feed is about babies, about people or women going into labors. So there is some kind of refined and optimized models are working in the background. So this is machine learning. There is another term, which is the deep learning. It's basically a subset of machine learning. It's more advanced type of machine learning that works well with images, sound, or unstructured data. For example, the self-driving car, recognizing a stop sign using camera footage. And there's also another term that you might hear of, which is the NLP, natural language processing. It's when computers understand or generate human language. For example, when you speak to Alexa or Siri, or you ask a question, NLP helps it understand and respond to you. Next slide. So now let's see how these technologies apply across the offshore wind cycle. And let's take a moment to understand first the offshore wind project development cycle, since not everyone here works with it day to day. An offshore wind project typically moves through 5 main phases. Number one is the site selection and planning. That takes anywhere between 3 to 5 years. And this is where developers identify potential areas based on water depth, wind resources, environmental, or the shipping constraints. And that's all in the first phase. The next phase is design and resource assessment, which also takes between 1 to 3 years. And in this phase, the engineers analyze the data, seabed conditions, and technical layout. The third phase is the construction and installation, which also takes between 1 to 2 years in average. And this is where it involves mobilizing vessels, foundations, cables, and turbine offshore. The fifth phase, or the fourth phase, is the operation and maintenance, the longest phase in the offshore wind life cycle. And this is when the wind farm generates power and requires continuous monitoring and repair. The last phase is decommissioning. This is when equipment reaches end of life and must be dismantled or recycled. Each of these steps generates huge amount of data, from wind speeds and seabed maps to vessel movement and maintenance logs. And this is where AI becomes super valuable. If you want to talk about AI application by phases, and I listed down here some of the examples that are partially news, are already news, or they are emerging technologies. For example, the site selection. AI can merge hundreds of data layers like seabed mapping, wildlife zones, shipping routes to identify the most valuable or the most viable lease areas. For example, the BOEM, the Bureau of Ocean Management and Ocean Energy Management, already uses AI or to be more specific, they use AI-assisted GIS to prioritize lease zones. In the design and resource assessments, machine learning models combine weather records, LiDAR data, ocean models to predict the long-term energy yields with higher accuracy and less certainty. In the construction, predictive algorithms schedule vessels and cranes around changing weather windows, minimizing downtime and cost. In the operation and maintenance, which is the most matured phase for AI nowadays, computer vision analyzes drone footage, for example, to detect corrosion or blade damage early. And the last phase in the decommissioning, even though we haven't had it here in the United States, but we have a couple of projects that have been decommissioned worldwide, AI simulations can help plan the most efficient removal sequence and maximizing recycling of turbine materials. So let's zoom into some of these phases, and starting with how AI changing early project development. Next slide, please. The first phase, as we mentioned, is the site selection. If you want to start with how AI changed the early project development, and AI is already changing how developers choose and plan offshore winds, because it's already, some of these technologies are already news, as I mentioned, some of them are partially news, and some of them are still emerging. But one of the area that has been currently in use is the geospatial optimization. Machine learning can layer data like water depth, wind speed, grid distance to find low-cost zones. For example, Arab's scale tool does this automatically. They test hundreds of scenarios in minutes to find the most optimized and the low-cost zone. Another example is the cable routing, which is partially in use, and I'm pretty sure cable manufacturers are doing this in the R&D, AI tools analyze seabed roughness and slope to find the safest, the most efficient cable path, and also permitting automation, which is emerging use currently. AI language tools like the NLP I mentioned earlier can summarize thousands of environmental comments or draft regulatory documents. These tools are being tested but not fully approved by agencies as far as I know. So once the site is chosen, the next challenge is estimating how much energy that site can produce. And that's where AI gets more technical. Next slide, please. So AI in wind resources. This stage defines the project value. Traditionally, it takes months of modeling. Now AI can do it faster and often more accurately. Some examples is Boxkite. They use AI to predict 20-year wind averages from just 1 year of measurement data. Another example is the DNV's CFD machine learning. It mimics the complex airflow simulations in a fraction of a time. NVIDIA's ForecastNet, they also use AI to forecast wind pattern 10 days ahead, which improves the power trading. Also, wake modeling. AI predicts how turbines affect each other's airflow to optimize layout. And this is all in this second phase. And after the project is built, the real challenge also begins now, which keep the turbines held for decades, which is the operation and maintenance. Next slide, please. Operations and maintenance can account for 30% of the total costs of the project. So any efficiency gain matters here. Predictive maintenance. This is, I'm sure many of you have heard of this words. This is when machine learning can detect unusual, let's say, vibration or temperature patterns weeks before failure occurs. And one of the example is the Siemens Gamesa. They use such systems to prevent gearbox breakdowns, which is a major failure component in the wind turbine, both onshore and offshore. Digital twins, virtual models of turbines or foundations simulate wear and help extend their lifespan. Autonomous inspections, drones, and underwater robots with AI vision can find cracks or corrosion without stopping operations. The reinforcement learning algorithms optimize vessel routes based on weather forecasts, cutting fuel, and downtime. So all of these examples are currently in use in this phase. So let's look at some companies that have already put these ideas into practice in the next slide. So these are some of the companies that have already used these AI tools into all of these phases. One is the BitBloom. They use AI to detect underperforming turbines and recover 2 to 4% of lost energy. This is a high percentage of lost energies that they are able to recover. Fugro, Ocean Infinity, and Oceaneering, they operate uncrewed AI-controlled vessels, which reduce the emissions by about 90%. PaleoScan uses AI to interpret the seismic data and choose foundation sites more accurately. ArabScale, the one I just mentioned earlier, they integrate environmental and cost data to identify optimal lease areas. Next slide. So where do we go next? Let's talk about the future possibilities that are starting to emerge. We're just scratching the surface of AI in this industry. One of the major area that AI can optimize is the mooring line monitoring. AI can track tension and alert operators before cable failures. Mooring line are used in the floating offshore wind technology, and mooring lines are leveraged from oil and gas industry. Nothing really new for the floating offshore wind or for the offshore wind. However, in the oil and gas industry, we used to have one platform, two platforms. Here in this industry, we're talking about hundreds of turbines, and each of these turbines needs at least 3 mooring lines. So tracking all of these mooring lines can be a hassle for anyone to do manually, and AI can make a revolution here by tracking the tension and alert the operators before a cable fails. The other domain is the generative AI for permitting. AI can draft compliance reports or public summaries automatically. If you happen to see the comments, the BOEM or BESI or NYSERDA receive on any of the application, like the EIA, for example, the environmental comments, hundreds of comments, probably thousands of comments. Generative AI can help draft these or filter these comments and give a nice summary instead of doing this manually in an accurate way, if the model is trained enough, is optimized enough to do this task. Of course, the grid optimization, the dynamic grid for hybrid hubs. Predictive systems balance wind, batteries, and hydrogen in real time. Autonomous robots that I mentioned earlier. It is still an emerging technology and still has a lot to do. The underwater crawlers using AI checks on wheels, scour protection, scour conditions. These are just some of the examples we can use AI for. Logistics optimization. AI predicts weather windows to schedule maintenance vessels and do this efficiency. But of course, we're talking about future AI applications, but this also comes with challenges and enablers, which takes us to the next slide, please. So to reach that future, we have to overcome few big challenges. And one of these challenges is the data fragmentation, which means that each turbine manufacturer has its own format because this is a niche industry. So there is a lack of data sharing standards like the IEC 61400, for example. Another challenge is the growing skills gap. Few people understand both AI and wind engineering, and that's the very reason that the Academy is focusing on this domain. Next slide, please. Some of the enablers, if you can go back one slide. Sorry, I put them both the challenges and the enablers for this. Some of the enablers is using the open frameworks like the Gaia-X or the DOE's Wind Data Hub that Department of Energy was working on. These two frameworks are helping with data access. Workforce programs such as the one that I mentioned, that the Offshore Wind Academy, training the next generation of digital professionals. And the key idea here is the AI amplifies human expertise. It doesn't replace it. And this is important to mention because many people are scared about how AI is going to take their jobs. They will not, but they will optimize your day-to-day job. Next slide, please. So in terms of key takeaways, digital twins and AI can extend turbine life by 5 to 10 years. Predictive analytics can reduce unplanned downtime by 30%. Data-driven maintenance can lower O&M costs by up to 15%. And if we combine AI with skilled people and open data, offshore wind can truly become the first fully digitalized renewable energy, and it is on the path to be in that position. Next slide. Okay, that's basically my next slide. So I'd like just to conclude and say that AI won't replace human intelligence, as I mentioned. it will enhance it. It will help us make faster, safer, and smarter decisions for sustainable energy. Thank you for joining. Probably I have a couple of minutes for the questions, so I look forward to your questions and discussions.
Yeah, thanks, Serena. We've had a number of questions come in, but folks on the line, please feel free to continue to send those in. What a great presentation, providing an overview on how AI is being incorporated or could be incorporated into the different development phases of offshore wind, from permitting through construction, getting into the manufacturing process, and finally that long-term O&M. Thinking about the questions, within these different areas, and particularly the operation, there's a growing concern about avian fatalities around wind farms. There's a question around, can AI help address that?
Yeah, this is an excellent question, and the answer is yes, absolutely. And this is a real concern, of course, and this is an area that I personally worked on. I have actually to mention, before I dive into how AI is helping in this domain, I have to mention that there is a huge misconception about avian fatalities around wind farms. And this is unfortunately, offshore wind is under the political microscope here, specifically here in the United States. The number of birds are killed by by turbine blades, is relatively small compared to the number of birds are killed colliding into our windows. Just a question for those who are attending. Do you know how many birds and avians are killed just colliding into our windows every year here in the United States? Just make a guess. It's 2 billion. 2 billion birds are killed just colliding into our windows. How many birds are killed colliding into wind turbines blades? Around 100,000. Still a number, but it's relatively small if we just want to put it in a percentage with the actual number. Yet in the offshore wind farms, we're trying to tackle this issue because especially the wind farms are built in a way, sometimes in the way of the endangered species migration on the East Coast or the West Coast. So we actually recently filed a utility patent at the American Offshore Wind Academy for an AI-based turbine curtailment optimization system that is designed specifically to protect bird species near the wind farms, because in the permitting process, you are required to shut down the entire operation if you have an event of endangered species flying through the wind farm. And this is, of course, very costly for developers. You're talking about 2 megawatt, 3 megawatt of operation and continuing pumping the electric into the grids. So shutting down the entire wind farm is so costly for the operator, for the developer, also for the grid. So instead of shutting down the entire wind farm, we worked actually on a system that uses a combination of camera, radar, and acoustic sensors to detect and classify birds' movement in real time. Also, we applied a deep learning model that predicts the flight trajectories and collision risk within seconds. So instead of applying a blanket curtailment, shutting down the entire wind farm, which reduces the energy yield, as I mentioned, it performs selective and predictive curtailment, just temporarily slowing or stopping specific turbines only when necessary. And I'm happy to talk about this. Because we just filed the patent, so we're actually now free to talk about it. So this balances the environmental protection with operation efficiency. With the early tests that we conducted, it suggests that AI-driven curtailment can reduce avian strikes by over 80% while maintaining most of the site's energy production. So there are solutions that we're working on, and this is one of the areas that that we are excited actually to find a solution for.
That's great to hear. And there's a lot of research and development going into like new products around AI and their impact on wind. Um, Another question that we had come in was more around the permitting and site investigation standpoint. So, have you seen AI being used for soil strength, parameter derivation, and soil unit identification and ground model development? Pretty specific.
Uh, this is a very good question. I'm not actually an expert GNG, but I know some companies are spending a good effort, especially their R&D teams, to identify or train models that can help them detect the type of soil to help them in the site selection, not from the governmental perspective, but from the operator or developer perspective. But I'm pretty sure something is growing in these markets, specifically that the companies I'm just thinking of are already emerging this technology, and I believe they are doing the prototype. So they are in the pilot phase of applying these AI models for specifically for the soil classification.
So we've got these new tools coming out, and offshore wind development, works across a broad group of stakeholders. So someone out there is asking, how can developers, regulators, and researchers collaborate to share AI information while protecting intellectual property and sensitive environmental information?
This is a good question, and this is really one of the barriers that stand out. As I mentioned earlier, the data fragmentation, because each turbine manufacturer and operators use different data formats, it is a challenge to standardize the process, even though the solution is to standardize this process, but it makes the integration difficult. And again, because we're talking about a niche industry, it is there is a limited transparency. Much of the data is proprietary. So smaller developers and researchers cannot easily access it. Um, could be the solution to come from the regulators, not from developers, because of the confidentiality around the data they collected. So the higher authority here should be the one in charge of standardizing the process for the operators and for the developers. Like, for example, the shared data platforms like the DOE's Wind Data Hub that we mentioned earlier, the open standards like the IEC 61400, across-disciplinary training programs. Such as the ones that we do at the Offshore Wind Academy. Once all of these pieces aligns, the AI adoption will scale naturally, and at certain point, it will reach a standardization level where all the all developers, operators, and regulatory can use that, which is actually an issue not just in the industry in general. Now we have zillions of tools for AI, and I was just reading the other day that the AI it's a bubble that might burst, like the .com back in the 1970s, because there's no standardization. So yes, it is a barrier, and from my perspective, the regulators are the one who have the authority to standardize the usage of AI tools.
Yeah, so thinking about that, what are some of the barriers slowing down AI adoption in the offshore wind industry?
The ones that I just mentioned earlier, the transparency, the limited transparency because of the data proprietary and the confidentiality about the tools, the data insufficiency, or not the insufficiency, it's the data fragmentation, and the skills gap are the main barriers. Also, we are in the phase where we see a lot of startups, and this is also a word for the startups and the entrepreneurs joining this webinar. When I was at Avangrid as a senior engineering manager, I wouldn't really exaggerate if I said every other week I got approached by a startup promising a predictive maintenance, promising 30% less cost from the AI tool they're working on. So at a certain point, I feel like there is a saturation, like I'm fulfilled with the amount of AI tools, with the amount of startups out there. They're always promising, and they all promise the same thing: predictive maintenance, 30% cut off. So having this can somehow validate the AI burst bubble that would burst, like theory. But on the other side, having a focused or joint force with other technologies or other companies can help the developers select the right tool for their application.
It's great. There's a lot of decision makers out there, and instances of companies talking about reducing costs, increasing efficiencies. So vetting these technologies is super important. Where do you see AI providing the most immediate value in offshore wind today?
Yeah, good question. I think the most immediate impact is in the operation and maintenance, as I mentioned earlier, because AI-powered predictive system can detect early signs of turbine failures weeks in advance. I mentioned the gearbox vibration, for example, but we have also the temperature anomalies and foundation stress. These allow operators to fix issues before they escalate. And this is not only cuts the downtime and costs, but also improves worker safety. And since fewer emergency repairs are needed offshore, digital twins are another active area. By combining sensor data and physics-based model, can or we can monitor structure fatigue and extend turbine life by several years using drones for inspecting the blades, which is already in use. This is some of the matured phase in the offshore wind life cycle where AI is heavily used. The drone doing inspection, doing the inspection for not just the blades damage, but the corrosion, the scour protection at the foundation, the uncrewed underwater um, drones that, or the autonomous vehicles that currently Fugro or Oceaneering or Ocean Infinity companies are working on. These are immediate use, and they provide immediate value in offshore wind today.
Yeah, that's great. We've got one more question and then we'll close things out. So a little bit of a statement here. Generative AI has tremendous potential. I think you've discussed that in length during the presentation today. It's going to be a great productivity tool. But what are your thoughts on the possible reduction in actual human learning from the process? Is there
What is the
any, I mean,
production on? Sorry, can you repeat the question?
what is the possible reduction in actual human learning? So if you got these AI tools going through conducting these analysis, what does that have on, for instance, a technician's ability to learn and experience and do these maintenance activities?
So the answer to this question has two sides, right? The first side is I look at the AI and the way that we use AI the same way that we use GPS. If you want to look 20 years ago, it was kind of embarrassing to say, okay, I'm using GPS to find out like how to reach my office in a using a faster route or go back home without stuck in the 93 traffic. But the reality is these tools help us really focus on something that matter more. We might not know it today, but after using the AI, after using these tools, we can free our minds to think about smarter or new or discover new processes for all of these AIs. I admit that I use AI tools on a regular basis, even though it makes me feel like I'm lazy sometimes. But on the other hand, I'm using this capability or this productivity I have throughout my day to focus on something that matter more. So I use AI as an operating assistant rather than replace my learning, let's say, objectives by using these AI. So I wouldn't really worry. It's the same kind of concerns that we used to exchange when, as I mentioned, with the GPS. start to be used, when the automatic driving cars. Now we're thinking about self-driving cars, which is another kind of concern that we're adding. But at some point, we would be surprised that one day we used manually used to use or drive the cars. So all of these new technologies always faced with resistance. This is the human nature, but I'm pretty sure that we can exploit it. We can direct it in a way that help us get smarter and also focus on things that matter for our time, because we only have 24 hours during the day. I'm a mother of 3, soon to be 4, hopefully. But can you imagine how much free time I have in my day to do day-to-day activities or day-to-day tasks? AI can help me expedite this process throughout my day, and this is really the hope.
No, this is great. I've got 2 kids at home, and they're always vying for my attention as well. Serene, we really appreciate the presentation today and the insights you brought around AI and its potential impact on advancing the offshore wind industry across the different phases of development. So thank you once again for joining us. And for everybody out there, thank you as well for coming to this Learning from the Experts webinar. A reminder that the webinar recording and presentation slides will be available on NYSERDA's website. Our next webinar in the series will be on Wednesday, November 19th. Jim Bennett and Ian Vaporel will discuss how America's offshore experience gained from oil development is informing the responsible and effective development of offshore wind energy. You can register for future webinars through our events page at wind.ny.gov. We also encourage you to check out past webinars in the series on NYSERDA's YouTube channel. If you'd like to request a topic or speaker for this series, please email us at offshorewind@nyserda.ny.gov or fill out a Learning from the Experts survey posted on our events page. Again, thanks for joining us, and we will see you next time.
Thank you so much, Peter, and thank you all for joining.